R.A. Miller Industries, or RAMI, is a manufacturer of commercial and military antennas. The assembly process for one of their most successful products, the blade antenna, has a notably low time efficiency. The purpose of this project was to explore possible systems that may be employed to increase the efficiency of this process. Observing the operator assemble a blade antenna, one main issue is apparent. The main components, called blades, are 5,000 thick stainless steel sheets that are very difficult to handle. Also, the blade antenna is a high variability product with many unique combinations of blades. Any new process had to accommodate this variability. To solve the problem, two primary solutions were explored. Due to COVID-19, the original plan to build an augmented picking system was altered to instead provide RAMI with a bill of materials and assembly instructions as well as the necessary PLC logic for the system. Additionally, a prototype for an automated blade singulator was to be made to prove that the blades could be handled autonomously.
The augmented pick system is designed to assist operators with the assembly of blade antennas and to reduce the time required to switch over the manufacturing process between antenna models. The system works by indicating the next blade in the assembly sequence with a green light and using sensors to determine when a blade has been picked up by the operator. This allows the system to guide the operator through the antenna build process and to detect if an antenna is being assembled incorrectly. The bins on the machine are interchangeable and can be swapped out in order to allow for the system to accommodate RAMI's full blade antenna product line and future antenna models. The operator is guided through the bin swap process by the HMI display screen on the operator control panel. These characteristics allow for the augmented pick system to meet the project specifications.
The concept behind the blade singulator was a device that could eject a single blade to the operator, removing the need for operators to fumble with blades to obtain one. The singulator was designed such that it would replace conventional bins on the augmented picking bin with some updates and optimizations to the device layout. The singulator is constructed out of premium materials with tight tolerances to enhance its performance. What started out as a 3D printed prototype is currently constructed out of stainless steel and aluminum to decrease the wear over time and increase the repeatability. Through testing, we proved that the singulator produced a significant decrease in the cycle time of the blade assembly process. Due to my current employment at RAMI, challenges with fabricating the unit were minimal.
The major challenges that were encountered throughout this project included narrowing down the open-ended scope of the project, as well as the abundance of product variety. Both of these challenges were conquered by completing numerous detailed design changes that resulted in the best possible solution for the customer.